Today we're going to go over a little bit on functions, more so a few main things, domain and range of a function, and then how do we identify if something is a function or not, right? So nothing super complicated today. We're going to go over those basics ideas on a function. You guys have probably heard me say the word function quite a bit, um, but we're going to go over a little more today, just kind of specifically on what those types of things mean. Really, a function in essence is kind of an equation, right? It's a specific type of equation that we use a lot, especially in high school math. It just basically means we can use a number, plug a number in, and then we get out an answer. And we just used a little more specific terms on that. Domain is that's the number that we plug in. Range, that is the numbers that we get out as answers, right? That's all that domain and range are. Domain is what kind of things are we plugging in, or what are we allowed to plug in. Range is the stuff that we get out, or the answers that are possible. And so just to give a few kind of simple examples, again, we're not going to go super in depth into this stuff right at this time, but here's some examples of some functions, essentially equations. And here I've just set up some different domains, right? Oftentimes when we put in domains, we put them in these kind of curly brackets there. But it's nothing scary, it's just a list of numbers, right? So here, if we had domain of 3, 5, and 10 for this particular equation, that means our range, and I'm going to do that with curly brackets, which is next to the letter P. You have to hold down Shift and then hit that one. There's square brackets right underneath. So you hit Shift to get them to be the curly brackets. And so then here, we just, again, domain means plug those numbers in. We're going to use those. So here we would use the number 3. 3 plus 7, 10 divided by 2. So we get 5. And then I would take and put in 5. 5 plus 7, 12 divided by 2, 6. Then we just go. Again, here, 10 plus 7 divided by 2. Well, that would be 8.5 because that's 17 divided by 2. And there's my range corresponding with this domain. And we could do that for each of these. We plug in -2. That'd be 4 plus 1, because when we take -2 times -2, we get +4. Plus 1 is 5. 0 plus 1, again, 4 plus 1, and then at last 9 plus 1, because 3 squared is 9. Then there's our range there. And we can do that for any one of these. 4 times 3, 12 minus 5, 15 minus 5, and there we get our range. And you can do the same thing, even if there's square roots or anything else, we just plug this number in. Here, 5 plus 2 is 7, and we're taking the square root of 7. You can always leave that in square root form, and which I'm going to do here, square root of 7. Or you could find the decimal value if you wanted to as well. But here we would have the next one would be 10 plus 2, so that's the square root of 12. And then the last one, 2/5 plus 2, so 2/5 of 5 is 2, plus 2 more is 4, and that would be the square root of 4, which is equal to 2, right? So the square root of 4 is equal to 2. And that's just how you do domain and range. Domain is what you can plug in. Range is what you get out of the answer. And you can also put those things down in point form as well. So this is the same thing, just a little bit smaller, so I could fit these in here. We can put them in as point form as well. If domain was 3, 5, and 10. The points just meaning we plugged in the number 3, we get 5 as an answer. That's where these two things are coming from. We plugged in 5, we got 6 as an answer. So, we could develop this one as well. I'm not going to go through the whole thing right now, but I'll leave it up there in the notes. Like we could say -2 and 5, because that was a possibility there. We could say 0 and 1. We plugged in 0, we got an answer of 1, and so on, right? Even down here with those weird ones, that's still okay. We could say we plugged in 1, and we got square root of 7 as an answer in there. Like, that's okay to put as well. You just put them as points, or you can have them separated by domain and range, but they mean the same thing. Essentially, domain is what we plug in, or our x values. Range is what we get out, or our y values, what we get as the answer. So that's domain and range in a nutshell, right? That's kind of the basics of how those things work. Second thing we're going to go over is how do we identify whether or not something is a function. And we can identify that in two ways. We can identify that by numbers, in other words, by using their domain and range, or we can identify that by a graph. And by identifying by domain and range, what we can't have happen is we can't have an X value that is repeated and gives us two separate answers. So in other words here, we cannot repeat X values, and then I'll put a little star here and get a different answer. Okay. And what I mean by that, if we went up into our functions back here, if I plug in the number 3 to this equation, we will always get an answer of 5. I can't come later and say, oh, I plugged in 3 and got an answer of 20, right? That would be wrong, right? I can't do that while using the same equation, right? We have to get a specific answer every single time out of that in order for something to be a function. We can't plug in an X value one time, get one answer, plug it in again and get a different answer. It will always come out to be the same thing. So in other words, I can't have something like 3, 8 and 3, 19, right? That won't work because that's saying, hey, I plugged in the number 3, but one time I got 8 and one time I got 19. That can't happen. So you can't repeat X values when you look at numbers. And what that means by a graph, if we repeat X values, that means if you did repeat an X value, vertically something would be the same. So what we check for on a graph is we check what's called the vertical line test, and meaning that if we were to ever draw a vertical line in, it would only ever cross one time. So the vertical line test means it only crosses once. That's how we check graphs. So to show a couple examples on there, if things are functions or not, to identify these types of things, again, here it's just in our point form rather than having our domain and range separate. They're just together. So I would just check along here and see, there's -1 as an X value. There's -3, there's 0, there's 2. None of the X values are repeated, so it's automatically a function. I don't need to check anything else. None of the X values are repeated. So then I'd go to the second one and see, okay, are the X values ever repeated, right? There's a 5, there's a 2, there's a 3, and here's another 5. So the X values were repeated here with the 5s. I'll highlight that one. Let's go in red, and I'll highlight this 5 in red. And notice they have two different answers. One gives an answer of -1. Maybe I'll highlight that one in blue. And this one gives an answer of 4. I'll highlight that one in, say, let's go like an orange color there. Okay. So they are not the same answers here, right? Meaning I plugged in 5 and got -1. The other time somebody plugged in 5 and got 4. That's not possible. The X values were repeated, so this is not a function. And no, that is not a function. And so then we go along here and we check, are any X values repeated? Right here we got -3, 4, 2, 0. There's no repetition of X values, so this is a function. Some people get a little bit, might take a look at this and say, hey, this one has a 0 here, a 0 here, a 0 here, and a 0 here. But two things there. Number one, Y values can be repeated. So that is okay for that to have a 0, 0, 0 in the Y values. It's okay. That just means somebody plugged in -3 and got 0. Somebody plugged in 4, got 0. Somebody plugged in 2, got 0. You can have an answer multiple times. That's okay. All right, the Y values can repeat. And then here, this X value never matches with another X value, right? There's no other X value that is also 0. These zeros are all Y values. So this X value of 0 at the very last one is actually not repeated ever. So this is a function. It's only when it's repeated and it gives you, a different Y value each time, then it is not a function. Okay? That's how we identify things by numbers. Okay? Last example here that we'll do on this one is to identify things by graphs, and we use what's called a vertical line test. So I'm just going to put in here a vertical line, right? So let me draw one that's straight up and down right here, and I'm just going to put that on top. We'll make it nice and thick so we can see that, and let's make it a nice bright color so we can see where that thing is. Okay, I'm gonna make that nice teal color in there. So in here, when we're checking whether or not something is a function, it has to pass the vertical line test. And by that I mean, so if I take this middle one, and I'm gonna check that that's a function, I would essentially move a vertical line over it and see, does this thing ever hit the vertical line more than one time? And we can see as this thing scans across, it never hits that more than once. It's always only hitting this thing ever at one point in time, right? So here it's only hitting one time. Here it's only hitting one time. So this one is a function because it only hits one time vertically at any point in time. You know, if I go through and check this one, right, I would scan over it and check that thing, see, does it ever hit vertically more than once? So even though this thing's kind of wavy, right, and a little bit different, it's called a sinusoidal function. Some of you guys that are in trig might be able to recognize that function. But those two are definitely functions. Let me make them a little smaller here so we can see those. And now, if I were to check this one, right, I might scan along this function here. Whoops, let's scan the other way. So I might scan along here, and it's okay. Right here, we're hitting it one time. However, once we get to this spot, notice it's hitting it multiple times, 1, 2, 3 times right there. So we can't hit more than once when we draw a vertical line in there. So this one would not be a function because it hits more than once. And then we can check the other two, right? We can check this one, right? We would scan across there and see, oh, yep, that only ever gets hit one time by a vertical line. So that one is a function. And this weird blob looking thing for sure is not a function because I could stick a vertical line right there and it hits it more than once. So this one is not a function. So that's how you identify things graphically to tell whether they are functions or not, because they have to pass the vertical line test. So that's the main stuff for today. Nothing super in depth, just a little bit different concept, conceptually a little bit different there. So if you do have any questions, make sure, just email me, post. Some of you guys have been doing very good at that. But again, if you have questions on that, don't be afraid, send me a message. I'll try and get back to you on those things, or I'll make a video or something. I'll get that across to you if things aren't quite making sense to you. But if they are and things are going just fine, have at it. All right. Talk to you guys later.